Hello, I'm Jose Falcon, and today I will be talking about how virtual skills has impacted my team's coding and programming skills and how our autonomous works.
Virtual skills has impacted my team's coding and programming skills in many helpful ways. It lets us test if our autonomous code would work as planned and lets us study and understand code. In the end, it's very helpful and an amazing resource.
To start off with the explanation of our code, we must first talk about how we separate the code into two different programs, one for the blue dispenser and one for the purple and yellow dispenser. In the one for the blue dispenser, we separate the drivetrain of the two motors into separate motors, so then we can use this sensor inside the smart motors called encoders, and with this sensor, we can sense if one of the motors is going slower than the other using operators and motor sensing. If one of the motors is going slower than the other, we can make it so that motor goes faster and then catches up to the other motor. Since in our robot, sometimes in the coding skills, one of the motors goes slower than the other, and that causes it to turn to the wrong side while it's driving straight forward. This is an example of said code. Now onto the positioning of the robot. In this code, we use the two motors that we talked about before, and we make them move at the same time, since now it's not the same. It's not like a group, and you have to code both of them to move at the same time. And then to get the amount of distance we want the robot to move, we have to calculate using the circumference of the wheel that the robot uses, and then we find out how much one turn of the motor would, how far the robot would go. And then we calculate how many turns we would need to get to the distance we want to, and then we put that into the amount of turns the robot needs to move. Here you can see that being in effect. In the end, all this code gets the robot to position itself right under the blue dispenser and lift it up, dropping all the discs onto the floor and doing the same thing with the other blue dispenser, ending up with 20 points.
This part of the code results in 20 points.
The second part of the code utilizes drivetrain code blocks, which uses both motors as a group instead of our old code, like how it was using it separately. So in here, we make the robot go forward, and then we use the turn to rotation blocks, which can make the robot turn to any specified angle out of a 360-degree angle radius, and then we make it turn to counterclockwise 90 degrees. And then we make it walk forward to the middle of the yellow dispenser at the front, and then we make it turn another clockwise 90 degrees again and push the yellow dispenser. In the end, taking all the discs out on the floor, which equals to 9 points. After the code for the yellow dispenser is done, we have a 3-second code block, which makes the program pause for exactly 3 seconds, giving us time to reposition the robot back at the starting position, and then place it right behind the purple dispenser wheel, and we make it move forwards and then turn the wheel at the same time, and then this results in turning the purple octagon, which releases the discs onto the floor, ending up with 8 points. In the end, our entire code ends up giving us 37 points.